Hello student, today we are going to solve excellent GATE question that has been asked in GATE 2016. You can look at the board for the question. The question is, a square plate of dimension L into L is subjected to a uniform pressure load P equals to 250 megapascal on its edges as shown in the figure. Assume the plane stress condition, the Young's modulus E equals to 200 gigapascal. The deformed shape is a square of dimension L minus 2 delta. If L equals to 2 meter and delta equals to 0.001 meter, the Poisson's ratio of the plate material is. Okay, so just look at the figure that has been given in the question. So this is the square plate of length L. The length of this plate is L. It is subjected to uniform pressure along both the edges, that is P. This pressure is P. The pressure P is applied along both the edges. So this is pressure P along both the edges. If just assume this direction as X direction and this direction as Y direction. These are the two directions, X direction and Y direction. One very important data is given in the question, that is assume the plane stress condition. Assume the plane stress condition. So first of all, we will see what is plane stress condition. Plane stress condition. Plane stress condition. Plane stress condition means that the stress in the third dimension is assumed to be 0. That is, these are the two dimensions, that is dimension X and that is dimension Y. So along the Z dimension, the stress is assumed to be 0. This is the first assumption for plane stress condition. And the second thing is about plane stress condition is that the third dimension compared to the other two dimension is negligible. That is, this dimension is L, this dimension is also L. So the dimension in the third direction is negligible as compared to these two dimensions. So these are the two conditions for plane stress condition. Now, let's see what is given in this question. This is P and this is P along X direction and Y direction. So we can say that the stress in X direction, that is sigma X, equals to minus P, and sigma Y, that is stress in Y direction, is also minus P. Okay, so in this question the Poisson's ratio is asked. Okay, so Poisson's ratio. So for Poisson's ratio, first of all, let's see what is the lateral strain, or I can say strain in X direction. Strain in X direction. Strain in X direction due to these two loads. Okay, so the strain in X direction is given by first a longitudinal strain that is in X direction, and that is given by sigma X by E. That is given by sigma X by E. And one more, that is longitudinal lateral strain due to load in Y direction. So that is given by minus mu sigma Y by E. So this is lateral strain due to load in Y direction. Okay. Now let's put the value of sigma X and sigma Y here. Sigma X, that is minus P by E, minus mu sigma Y, that is also minus P by E. So I can say plus P by E. So this is the strain in X direction. And what is the total change in length in X direction? This is given as delta. So this is delta, this is delta. So total change in length in X direction is 2 delta. So I can say minus 2 delta divided by length, that is strain in X direction, change in length upon original length, is given by minus P by E plus mu P by E. So let's arrange this. Minus 2 delta into E divided by PL equals to minus 1 plus mu. Okay, so mu is given by mu equals to 1 minus 2 delta E divided by PL. Now let's just put the values value of delta E and P and L. Just put the values to. So mu is equal to 1 minus 2. Delta is given in the question, that is 0.001, 0.001 delta is given. E is given in 200 gigapascal, means 200 into 10 to the power 9 Newton per meter square. Okay. Upon P is given as 250 megapascal in the question. 250 into 10 to the power 6, that is 250 into 10 to the power 6 Newton per meter square. We have to put the values in SI units. Length. And the length is given as 2 meter. The length is given as 2 meter. Now, just solve this. So from here, you can get the value. So by solving this, we can get the value of mu equals to 0.2. So in this question, generally a common mistake we used to do, that we used to analyze this by volumetric strain formula. So here we don't have to apply the volumetric strain formula. We have to just apply the longitudinal strain formula, that is epsilon x or epsilon y. You can solve it by epsilon x or epsilon y. You will get the same answer, that is 0.2. So the correct answer for the Poisson's ratio is, that is 0.2. Thank you. Keep watching.